You want to say hi to Mom?
Hi, Mom. She doesn't even watch this. I know.
She might. You never know. Okay, that's right. Now when you guys tell her the stories about what happened in math class, I'll say, yeah, just watch the video, Mom, and see if that indeed is true. All right, 6.5, simplifying. All right, what today's lesson basically is a review of adding like terms. However, we've got to deal with fractions. So remember how we added like terms. And stop clicking or you're going to lose your pen. Remember how we added like terms. That'll be on the video too. Remember how we added like terms. All right, so something like this, 9x plus 4x. And remember, the concept is this. The things are x's. We have 9 of them and 4 more of them, right? So 9 of them plus 4 of them equals 13 of them. And what are they? That should have been green. I don't know why it turned out red. Should have been 13 of them and 13 what's? 13 x's, right? You just add the coefficients. Add the coefficients. 9 of them and 4 more of them is 13 of them. 13 what's? 13 x's. Now, if you were going to be technical, the way to do it is put the coefficients in a parentheses and whatever the thing is behind it. 9 of them plus 4 of them. But usually they're so easy that this step isn't, it just really gets in the way sometimes, but technically that's what's going on. And again, of course, we end up with 13 of them, right? You're just adding up like terms. They have to be the same thing to add them up. Can you add up x's and n's?
No.
No. They're not like terms. Just like you can't add apples and oranges. Did I say oranges or oranges?
Oranges.
I lost my Jersey accent for a second there. They're oranges, not oranges. What in the world? I'm getting corrupted. My great Jersey accent's getting corrupted. What a shame. They're not oranges, they're oranges. Yeah. It's a city in New Jersey called East Orange. Orange, not orange. Potato, potato. Tomato, tomato. All right, so anyhow, just to review. So technically, if we were going to do B technically, we would say negative 12 minus 5, right? But again, in regular thought, we'd say a minus 12 of them and another minus 5 of them gives you minus 17 of them, right? A negative 17n. So in this example, we have to be careful with what are like terms. Let's use our red here. There's a y squared, right? And here's another y squared. Notice my box always includes the sign and whatever number there is. So in this example, the first box has how many y squareds? And the second box has how many y squareds? Negative 1, right? Negative 1. So again, if you were to stop talking out loud, so technically, if you were going to write it, you would be 10 minus 1, right? 10 positives and 1 negative leaves you 9 positives. And there's a positive 9 y squareds. We'll do the second one here in blue. The other like terms are the negative 5y. Again, I always box in the sign along with the coefficient term, and a positive 2y. So again, in our head, And I don't think we need to do the technical part, except with when you do fractions. You can't do fractions in your head, so we got to do the fractions technically, right? That's the only reason we're reviewing this. So 5 negatives and 2 positives leaves you 3 negatives. But again, technically it would look like this: -5 plus 2 of them, which of course is a -3 of them, right? And then be careful, in this example, there's still this -8 tacked onto the end that we can't add up with anything, right? Because it's just a number. You can't add an 8 and a -3y. That would be an example like this. 4 ounces of gold plus an apple is 4 ounces of gold plus an apple. Or 4 ounces of gold plus 8 is 4 ounces of gold plus 8. They're not like terms either. You can't do anything else. Chloe. Oh, there is a 1. Did I miss it? You're right. So here, so this is actually not -8, but it is -7. 7 negatives left. Thank you. Lost my 1. So that's 9y squared minus 3y minus 7. So what happens now is we've got fractions for coefficients. Now this first example is not bad, and you really could do the first example in your head. We're going to do it technically. So we're going to use a parentheses. And we're going to say there's 4/5 of them plus 3/5 of them. Do you concur? And the them is the x's, right? And that's the way it would look technically. So of course I'm going to show the rule step. Right? 4 plus 3 over 5 of them. And our final answer is 7/5 x. Edward.
Can we, in the parentheses, just skip writing that and just put the rule step in there?
I'd rather not right now. After this lesson, yes. But just for the lesson's sake, while we're trying to get everything technically wired in our brain, not yet. It's just one more step, and it's not a big deal because we're not going to do a ton of these. And honestly, Edward, this was an easy one in that they had the same denominator. We're really working toward when we don't have the same denominator, at which case you're not ready for the rule step anyhow. Okay? Which is this example. So on this one, obviously we have A's and B's, and I color-coded them for you, right? So let's go ahead and do our A's first. We'll do them in red. So somebody tell me what to write in the parentheses for the A's. Kristen?
1/5a minus 2a.
Not quite. Somebody else tell me what to write in the parentheses. Luke?
1/5 minus 2/1.
Okay. So I'll just write the 2 for now, and we'll get to that over 1. I agree. Christian, you put your A inside, and there's no A inside, right? The A is outside, right? There's 1/5 of the 1/5 minus 2 of the A's, right? Okay, and then we need to deal with our B's. Now, whenever you're doing this, you can always put a plus sign in between, and we need to. Somebody tell me what to put in the parentheses for the B's. Allison? Would be 3 plus the 3/4, right? And those are B's. So in the first example now, we'll put the 2 over 1 and we'll put the 3 over 1. So now, when you look at let's do the red one first, the A's. Somebody tell me what to do next to be able to do the A's. Christina? Tell me what to do. Emily? Okay, and what's the common denominator? So what do you want to do to get that common denominator? Okay, so I think what Emily said is, with the 2 over 1, Multiply the bottom by 5, and whatever you do to the bottom, do the same thing at the top. Do you agree? So, Edward, I'm okay with you doing getting the common denominator on top of that step. I don't have a problem with that. It saves you a step. And now we'll go right to the rule step. So we have a 1 minus 10 over a 5. Do you agree? And it's that many A's. We'll finish that in a moment. Let's deal with our green. So what are we going to do with our green ones? Ashley? Correct. We need a 4 on the bottom of the 3 over 1, so whatever we do to the bottom, we'll do the same thing at the top. So that's a 4 over 4. And now we're looking at rule step here, 12 plus 3 over 4 of the B's. So somebody tell me how many of the A's do we have? Colby? I agree. Colby said 1 positive and 10 negatives leaves you 9 negatives. And somebody tell me how many of the green we have. Luke? 15 fourths B's. And you know what? None of those reduce. None of those reduce. So that's the final answer, 9/5 A plus 15 fourths B. Not so bad. Just got to keep track of things. You know what it really is? It's like 2 problems in one, sometimes 3, because you could have different things that you're adding up. All right? Questions on that? Christina?
You're not solving it.
That's as far as you can go with it. You can't go any further because you can't add the A's and the B's. They don't add. Can't add them up. They're not like times. Okay, so let's look at this last example. This last example has 3 things. So I'm going to pause the video, and I want you guys to see if you can get this example correct. Okay, so again, I asked you for the best form. And those negative signs sometimes can cause you trouble. Now, there's 2 ways to deal with them. I like to deal with them with a plus and then keep the negative with the fraction. But you can do it the other way as well, as long as you don't double the negative. So on 3, give me your answer. All right, here we go. 1, 2, 3.
7x squared
Okay, I heard some correct answers, but I heard it in not the best form. So I think I heard this, right? 7x squared plus negative 29 over 24x minus 7. What's a plus times a minus? What's a plus times a minus? A minus. So see how we can further one more step simplify that? So if you got to the blue box, that's great. Just take it one more step, and because you have this plus times this minus, you can care for it with just a minus in the front. Okay? So how many got that? Either the blue box or the green. Awesome. That's great. And you're definitely understanding. You've got the concept. Questions on this one? Questions? Questions? Anybody from the peanut gallery? Questions? Okay, let's work a few problems. So grab your book. I'm just going to work a few problems for the rest of the class period. Let's see if we can find something worthy. 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 Let's try 22 first off. It's 8 over 7x squared. This is page 243. Minus 6x plus x squared minus 7x. 8 over 7x squared minus 6x plus x squared minus 7x. Try that on for size. This is page 243, number 22. Skidoo. You can do it in your book. You can do it on a piece of scratch paper. Whatever. Whatever. Ooh, still recording. Let me pause while you guys work on that. All right, on 3, give me your solution. 1, 2, 3.
15 over 7x squared minus 13x.
All right, I heard that plus negative again, right? Got to learn. We're human beings. Human beings learn, right? We learn. So, yeah, you don't need that plus minus, right? Because, again, a positive times a negative is a negative. And by the way, just watch, follow me for a second. Honestly, if I were going to do this problem, I would do this part like this. But this part, I would say 6 negatives and 7 more negatives is 13 negatives of them. And I would do that for that part. No need to do the parentheses when it's just whole numbers, right? A negative 6 of them and 7 more negatives of them is 13 negatives of them. And we could have just done negative 13x all the way down. Follow? Makes sense? Again, the fractions we got to deal with because we got to get those common denominators. But the whole numbers we know how to do, and we can just add them up like regular, like times. Let's do another. Oh, that is a granddaddy of them all. We ready for the granddaddy? I think we're ready for the granddaddy of them all. Yeah. This one is awesome. I'm just so excited. Can't wait. What fun. Number 28. Oh, man, it's great. Negative 3/5 parentheses 5x squared minus 3x plus 7. What an awesome problem. Close the parentheses. Plus 2/5 parentheses x minus 2/3. Close the parentheses. What an awesome problem. All right, this is definitely the grand finale. Let me pause the video. See if you can do it. Here, just to make sure everybody's brain is thinking correctly. What do we have to do first? What's it called, the thing we do first? Colby? Well, but what's the thing called that we're going to do? Luke? Well, it comes from this. What property are we going to do first? Distributive property, okay? You got to distribute first. Okay, go ahead. Okay, so in this problem, first thing you had to do was distribute, which means you had to distribute the negative 3/5. Just watch. You don't need to write it. The negative 3/5 to every term, and that's what I did right here. I also had to distribute the 2/5 to both terms, and that's right here. So now I had to see what all that stuff was. And that gave me now this right here. Well, there was no other x squareds, so that just stayed all the way through. But I now had to do my x's, and that's right here. I also had to do my numbers, which that is right here. Again, common denominators if you need them, add the numerators, put them over the common denominator, and away you go. As I said, that one was quite interesting and quite hard. Was anybody on their way at least to heading toward that one? All right, well, it didn't help that I didn't freeze it. So, all right, well, that's the idea. Again, you won't see anything that difficult yet. I'm not sure half the Algebra 1 students would get that one correct. All right, but the principle is this with the like terms. When you have fractions, just group the fractions, the coefficients. Let's do one more so we can finish on a positive note. So last one, I'm just going to make it up. What would you guys do with this? Negative 3/5 n plus 1/3 n minus 3/4 n. Go ahead and do that one. Last one. Grand finale. Now I'm going to pause it. All right, on 3, give me your answer. 1, 2, 3. Oh, what a shame. Negative 61 over 60, right? Should have had a negative 36 plus 20 minus 45 over 60. No homework tonight as we get ready for Christmas break.